Hi, this is the module Alarm Templates within DataMiner Configurator Level 1. And in this module, we'll take a closer look at how to create an alarm template and define the alarming of all your parameters in your elements. The previous module, we saw the trend templates, defining which parameters are activated for trending. Within the alarm templates, it's exactly the same principle, but it's a little bit more features around all the alarming possibilities we have in the DataMiner system. Let's take a look at that. So first of all, we'll create an alarm template. So the same principle as a trend template, and we will assign it to our test element to play around a little bit with just the basics, a couple of alarm thresholds. And then in the next step, we'll take a closer look at configuring all the different possibilities with the alarm templates. There's a lot of possibilities with alarming because that is very important in a DataMiner system. We already took quite some time to take a look at the features in the alarm console. Now we want to take a closer look at how to define that alarming, when the thresholds are met, when the alarms need to be activated. There's a lot of special conditions and all kinds of features around the alarming because we want to make sure that our alarming is accurate. That's a very important thing. And that's also a little tip I want to give, that you continuously need to try to fine-tune your alarm templates and make sure, like, okay, we have too many alarms. Let's activate certain features to make sure that only an alarm happens whenever there is a condition that needs the attention of the operator. Or if something was not picked up, you need to activate that alarm template or those thresholds on those additional parameters. So always make sure that you continuously evaluate your alarm templates and have accurate alarming. You don't want to have an alarm console with thousands of alarms in there that clutters the situation for the operator, or you also don't want to have like an empty one and whenever a problem happens you don't have an alarm. It's a very foundational configuration, those alarm templates, and therefore they have lots of features, lots of useful features in there as well. We'll take a look at that in the configuring parts. And then, of course, assigning, we know how that works already, but just a little recap on that. And then we have a special thing with alarm templates. It doesn't exist on trend templates, but with alarm templates, you can group them. You can stack them on top of each other. That's a special thing that is added to those alarm templates for easier management and maintainability of several templates that we have in a system. And a little exercise to wrap it up. Okay. So first thing is creating our very first alarm template. We'll immediately assign it and we'll immediately play around with some of the basics to see the alarms popping up in our system. So the first thing we need to do is we need to go again to that templates section. As with the trend templates, the alarm templates are located in the same area. So we go to the apps section in our sidebar, and there we can go to the protocols and templates app. So the protocols and templates app is what we need. If we open up the protocols and templates app, we already covered the management of the protocols. So if we select our protocol, we typically go for the production version. We now know that production version should be our default. So that's by default selected. So that should be fine. The top one, production. And then we can see the section with our templates in the third column. And we already focused on the trend templates. We created one. And now we're going to focus on the alarms section here, all the alarm templates that are available. You will always have that no monitoring in there. That's always going to be available. And you can just use the right click menu to right click on any of the existing alarm templates or on the no monitoring to go for a new one, which gives you a pop-up where you can specify the name. Protocol and version should be okay. And remember that group will pop up at the end, so we don't need to worry about that. We will just create a new alarm template in the right-click menu and give it a name. There's also duplicates if you want to duplicate an existing one, or delete is available there as well. All right, so be aware there are multiple alarm templates that we can create, of course. So we can create alarm templates with kind of strict thresholds for a series of elements, and maybe some alarm template which has a little bit wider, less strict thresholds for other elements. So depending on where my elements are and if they need different alarms, I can have, of course, a series of different thresholds for different environments, for instance. But we'll also see that we have lots of features in the alarm template that allows you to try to use one kind of more dynamic alarm template for more elements than just with fixed thresholds. So there are some more goodies there. So first things first, we're going to create a new one by going over there and right click and new. I'll immediately do that in an example, but let's first take a look at what happens then. It's similar as with the trend templates. It will pop up with a list of all the parameters that are available in my data display. Well, same thing as with the trend templates, it's going to give you a selection. So the developer of a connector, if they add parameters in a connector, they can make the parameter available on the data display, but then they have the option to like, oh, is it useful for trending? And is it useful for alarming? Do you want to show it in there? So it's up to the developer of a connector to make it also visible in the alarm template editor. So if you have way too many parameters in there with things like the name of the device, the date, time coming back from the element, those are typical parameters which are not useful for alarming. So we can hide them away. So you can provide that feedback if there would be too many parameters. If parameters are missing, then you can also contact the developer or contact us to get those and make those available in the alarm template. Now be aware, as with the trend template, the first time you open up a trend template, the new one, all the parameters are there. If you select a couple of checkboxes, you save it, you open it again, it only shows the selected items. That's because by default, if you reopen an existing template, it only shows the ones that are activated. And with this button on the upper right hand side, you can go back to show all the protocol parameters. So you can easily go back there. I'll do that in our exercise in just a second as well. So this one is actually an alarm template which is being reopened because there are only 2 parameters, and normally there are typically more parameters on the audio page. So only the ones that are selected are shown here. So with the trend template, we were only able to select average and real-time trending. Here we can basically only select monitoring enabled or disabled. That's the most important checkbox, you could say, that we have available there. If you click on activate the alarming for instance, the audio output level, it will immediately activate the whole row, and there typically are already some default thresholds that are being provided by the developer of the connector. So the connector can already suggest, you could say, some default thresholds out of the box coming from the driver. But there are lots of other options and things we will discuss, but first we'll go through the basics and start by activating some alarming on an audio output level, set some thresholds there, play around with multiple thresholds. I'll come back to that. This is a hybrid parameter with an analog and a discrete. There's a not used exception there on this one. And the LMB1 supply is like an on-off, so a discrete will also play around with that one. So let's do that and go to our training system. So I just go to our training platform, and there you typically have your own elements to play around with. I have here a trainer element which is already opened, and if I would go to the edits of this element, you would see that the alarm template is currently no monitoring, so nothing is assigned to this element yet, and therefore indeed no alarming is there, and there is no color coding as well. So it doesn't say even green because we don't know, there is no monitoring, so nothing is initialized in terms of alarming on this element, not even green. Okay, so let's create a brand new one. So we go to the apps, and then we go to protocols and templates. And then we go to the correct protocol, which is in this case the Philips. So you can also type in there. You go to Philips DVS 3810, production version is fine. And then we will see that we already have some existing alarm templates, the no monitoring. So yeah, next to it, you can see a little bit gray font there, how many are using it. And you can see the no monitoring. There are 2 of them not using this no monitoring, which is my trainer element and my trainer element replicated. Okay, so we're going to create, forget about the existing ones, we're going to create a brand new one by right-clicking on the no monitoring and go for new. And I call this one training underscore Bert. Okay, all the other things are just fine. I'm not going to talk about groups at this moment now. So just an alarm template with that name, and it comes up with all the different possible parameters that are available for alarming on that data display. As I mentioned, not all the parameters are there, but the ones that are meaningful for alarming should be in here. If not, let us know. As I said, the basics are actually very similar to trending. And if we just stick to the basics, it's just activating one checkbox for enabling the alarming or the monitoring. So if I enable the alarming or the monitoring on the audio output level, I can see there are already some thresholds that are defined. If I'm happy with that, I can just apply whatever I have. And then it comes up immediately like, oh, do you maybe want to assign it already to an element? Well, actually, yes, because my element is still using no monitoring. So let's immediately assign that, yes. And it comes up with that pop-up to say like, okay, let's go for my trainer element. I can search here my trainer element and move it to the right. So this one will be using my new alarm template. Okay, so I created my training Bert alarm template, and I immediately assigned it to my training element. So let's now go back to the surveyor. You can see there is already some monitor that's even in critical now. So let me right click and open a new card so that I can have it side by side in just a second, but let's open up maximize now. So you can see that the audio output level is indeed currently being monitored. So I can put it, for instance, on 6. So I just type 6 in there and I hit enter, or you click on the green checkbox. I typically hit enter to go a little bit faster. So that's how I quickly set it to a new value. Okay, so I activate it. Let me put it side by side. Let me open up that training Bert template again. So remember, if I created a new one, it had all the parameters in there and I could enable the checkboxes. If I now right click and I open up this one, or I double click on it, it will show you only the parameters that are activated for monitoring, which is only this one. So yeah, what are all my other parameters? For instance, I wanted to activate also the left test level and the right test level. Indeed, on the upper section there, you can click on, now it only shows the monitored parameters. Show me the protocol parameters again, and then I can also activate left test level, right test level, and hit apply. And you will see on the right-hand side, I have those also now activated. Now maybe I can also put them in green, so put them on 10, for instance. Or 10 is not a correct value. Can I put it on 10? It's minus 10, sorry. Minus 10, okay, that will be better. It's minus 9. It has a step size of 3, so minus 9. Okay, it's not so easy to set a right or test level. All right, don't worry about the include exclusion here that pops up. I can disable that again. It's under the settings. I'll talk about that later in the template groups. So again, the left and right test level, I activated those as well, and they already had some thresholds defined in there. So therefore, I already had some monitoring immediately out of the box. Okay, so that's how I can easily and quickly activate some parameters and have the monitoring available. But of course, the defaults that are provided by that developer, they are not the things that I want. I want to have my own thresholds. So I can just click in any of the cells there and define a new value. For instance, the normal value that I expect is 9. It doesn't really matter if it's 6 or 9, it will still be in the green zone, because the green zone is going from the tree only at 3. Or let me maybe show it here. So only lower than 3 will go into the warning and higher than 15. But still there is some kind of indication that 6 is the normal expected value. If I, let me put it side by side again and let me minimize this one. If I put it on 9 and if I apply, you will see that the normal value is that near 9. But you don't necessarily need to use that. So if I just remove and make it blank, the normal value, apply that, then we don't just have a normal value. It's just a small indication, not necessary to use it. But maybe at 12, I already want to have a yellow or major alarm. I always have to have a little peek at the alarm console to look at that. Those are, you can also see it here in the major. So now I added an additional threshold also for major alarms. You can also, for instance, for minor alarms, add one. And then it's going to be at 9, for instance. Apply that. So now also at 9, it will add an additional threshold there. You don't need to use all the thresholds. So for instance, the warning is currently not in use yet. I can maybe put the 6 here again so that we can nicely see 6, 9, 12, 15 all next to each other. Okay, so that's how it works to define those different thresholds. You can define the thresholds, of course, on the high side, and you can also define it on the low side. So on the right-hand side and on the left-hand side, if it's too high or if it's too low, you can define your thresholds there. Okay, so that is the thresholds on the audio output level. There is one more special thing that I want to mention, because if you click on one of those zones or values, you will see that there is a plus sign next to that. So what is that plus sign? Well, typically if I would go to, for instance, 15, and it goes higher and higher and higher, and suddenly it goes into alarm. It's at 15, it reaches the threshold there. So now an alarm, as you can see in my alarm console, an alarm is being generated there on my training element, 15 dBm. But what happens if it further increases to 18? Well, then it doesn't change the alarm anymore. And if it further goes to even a higher number, which is not possible in this case, it would never update that anymore, because it only shows the value whenever it reaches the threshold. And then what further happens, well, take a look at the trending, I would say. But in some cases you could say like, yeah, okay, but still I want it to be visible if it would ever reach 18, because then for the operator it will be visible if it's a 15 or an 18. That might be still a difference. Well, let's go back to the original situation, and let's now first change our alarm template. What we will do is we will click once again on the 15. We'll leave the 15 as it is. We'll click on the plus, and it adds an additional line in there. We add the 18 in there, in that extra line, and remove the focus somewhere else. And now we can see that 15 semicolon 18 is in there. And if I click again, I have two edit boxes, basically the 15 and the 18, to edit them. And if I remove my focus, I have them enumerated with or separated with semicolon. So now I have two thresholds for critical. So it will always go into critical as soon as I reach the 15. So let's go back to 15, and immediately my alarm is there. But if I now further increase and it goes to 18, my existing alarm here will be, did I update to, no, I did not update to 18. 18, let's go. 18. So whenever it reaches the 18, it reaches the 18, and my element audio output level does not show the 18. Why does it not show the 18? Because I did not apply my alarm template. demo failed. So let's go back to 6. I forgot to apply and save my templates. So let's start again. Now I saved it. Let's go back to 15 first. 15, the alarm pops up at 15, and if it further increases to 18, now the alarm will be updated to 18, there it is, and 18, and we see the history tracking. It was started as a critical 15, and then it went to a critical still, but 18. So that's the subtle difference you can have there. If it would actually reach a very high critical value, that even that value would be reflected in the alarm. So that's a small extra thing that you can do in the alarm template there. So that's the regular thresholds of a parameter like an audio output level, a CPU load, a bitrate, all of these things. Let me see, I do believe we have somewhere, do we have a signals? We don't have an exceptional value on these ones. We don't have a hybrid here in the example, but there was one in the slides, which basically allows you to click on there, and it still has a drop down below it with the exceptional value. The drop down is the same as the LMB1 supply. Let me disable this one again. The LMB1 supply, that's a very simple one. The LMB1 supply, let me maybe maximize it. It's just an on-off. And by default, on is okay, normal, off is a critical alarm. Maybe I'm not happy, maybe it should be a major or a minor. You can just click on the major and put the off in there. If you put the off in there and you move the focus away, then it just jumps over there. You can only have it in one of the columns, of course. It doesn't make a difference between the low and the high because, yeah, an LMB1 supply on or off, yeah, there's no such thing as an on high or an on low or something like that. It's just on off. So there is no distinction between the left or right hand side. If I have multiple values, then for instance, no card, valid card, card not responding, unknown card. So those are all different options. So only the valid one is in there. But maybe the card, unknown card is a major alarm. So we can move that one in there. And so we can move the different values in the different sections or alarm thresholds, of course. Okay, so that's a discrete parameter, that's an analog parameter, and remember that there is also a hybrid. If I have like a drop down on underneath there, a little bit like the little plus thing that comes along with it, you do have the possibility, I believe it's in the slides, let's check it out here. The not used, for instance, that is in here is an exceptional value that is next to an analog one. Okay. So and I now activated it for the LMB1 supply. Let's just do the on-off default, critical, and normal. Let's apply that and let's take a look at our elements. Let's go to the demodulator setup, and there you have that LMB1 supply on. If I toggle it with the toggle button, it goes to off and it goes into critical alarm. Okay. That's how simple it is. We are able to create a new alarm template, to activate the monitoring, and to specify those thresholds within that section. We didn't worry about the other columns yet. We just went for the most important things there, the different thresholds from normal, warning, minor, major, and critical. Okay, so we should be able to define and activate the alarming on some analog parameters, discrete parameters, and hybrid parameters, and define our thresholds in there. Okay, so we were able already to have the basic monitoring, like we had the trending. It is the same principle, you could say, but there are some more columns and some more features to it. So now we're going to dive a little bit more in depth into the alarm templates and see a little bit more what we have there in terms of features. The very first one is still a kind of simple one, or not that simple, but a recap, you could say, of the trending, because trending has it as well. I mentioned during the trend templates that we have in those connectors many tables, lots of data coming back from all kinds of data sources and services in the cloud and things like that, where you have tables of information with a lot of rows and a lot of columns in there. And typically, yeah, you want to have some alarming or trending on all of these columns or rows or cells in there. So you want to make sure that you are able to handle these kind of tables very well. So same principle, we will be using a filter there to define on which rows you want to activate the alarming. And let's take a look at that. It's a little bit of a recap. It's the same thing we did with the trending. So we will apply that on our Microsoft element again, and I'll do that again on our training system or our DAS system that we started during the very first fundamentals session there. We created a DAS, and the DAS did have a Microsoft platform on there. Okay, but we created our own element, our very first element there with BERT Training Microsoft. And on there, if I take a look at the edit, we created our standard trend template, but no alarming yet. So what I will do is create some alarming. We activated the trending on a couple of parameters, and in the task manager, that's what we want to look at now. In that task manager, we have a table of all the processes. And if we scroll down, we will see the CPU column. So that's this column here is not activated for trending, except for all the processes that started with SL, but we made an exception for SL log, and we also added at the very bottom the WMI processes. Let's do exactly the same thing for monitoring. So let's create a new alarm template for this one. Well, we're not going to go to the app, protocols and templates. We're going to go for right click and use one of those shortcuts located in the protocols and templates subsection. So here you can immediately assign an existing alarm template, which is not that what I want. I want to actually create a new one, which is also in here, new alarm template. All right, and it immediately gives me the pop-up to say, give me a name, and I'm going to go for a good standard alarm template for this Microsoft server and apply that. And I can immediately, let's just activate maybe something to take a look at that total processor loads. I'm happy with the standard alarm templates. Let me see if I save that or if I apply that. If I will have that immediately on there, yes, and I can see that my on the performance page, the total processor load immediately has those ones activated. So I made a little shortcut there using the right-click menu, the protocols and templates. I went for assigning a new alarm template from there. Okay, we already did with the audio output level a little bit of the regular alarming on an analog parameter, but we want to go for that task manager. So here in that task manager, same thing as with the trend template, we want not only trending enabled on the CPU column, but we also want to have monitoring enabled on there. So if we enable the monitoring, and we can say like, yeah, like normal value for CPU loads, if it's 0, 1, 2, doesn't really matter, but I want to have more alarming on there. For instance, as soon as it goes above 10%, then I want to have like a warning alarm. And as soon as it goes above 30%, for instance, I want to have a major alarm. You can see here not available is also an exceptional value. If the CPU load is not available, if the process disappears, I can also generate an alarm. You might have noticed if I was typing here and I started typing 3, it says like this limit is invalid. Well, indeed, because I already have a 10 defined here, then I cannot say that a major high starts at 3. It needs to be at least higher than the 10. So it needs to be at least 11 before that error will go away. As soon as I say 10, it will say, oh, that's not good. It needs to be higher than the 10 because it should be a higher threshold, of course. Otherwise, we're defining conflicting thresholds. Okay, I'm happy with the 30 and the 10 on. Let's just activate it on all the CPU columns or all the CPU rows, all the processes. So let's apply this one. Okay, and let's see if I can move a little bit of screen real estate to our element and go to that task manager. Oh, indeed, we can see the task manager has indeed now the green background on that full CPU column, all of the processes. But I'm not interested in Notepad and all of these processes. So let's scroll a little bit down and let's go to those SL processes, bring them in the picture. So like with the trending, I only want the monitoring to happen on that one. So therefore, I have that filter column in our template, which comes in handy and says like SL star, apply that one. And indeed, now the green background is only on those SL processes. We should not forget about our WMI processes. So how does that work again? We duplicate a row by clicking on the plus sign. And then for that second row, it's not SL, but it's WMI. And we apply that. And you can see that I deliberately changed the casing a little bit with small w, and here it has a capital W. So just to indicate you that this is case insensitive. My WMI processes are again activated now for, or are now also activated for monitoring, as they were also for trending. Now let's go back to that special case where we have the SL. The SL log, the SL log doesn't have any trending. We also want to remove it from the thresholds here, or from the alarming. So therefore we need to put another row in there. And remember that the order is important. If I need to make sure that the most restrictive of it goes top to bottom. So it will first check if it matches the first entry. If it matches the first entry, it will use those thresholds. If it doesn't match, it goes to the next one until it finds a match, or it doesn't find a match, then there is no trending or alarming. Now, yeah, I don't want to have, I could have alternative thresholds. And for instance, say like, okay, yeah, this is 15, for instance. I could do that, but actually in this case, I don't want any monitoring. So I can also disable this one and indicate that I don't want to have any monitoring for the SL log. And if I now apply that one, you will see that the SL log doesn't have the alarm color coding anymore. So be aware, if I would change the order, let's just play around with it and apply that. Now SL log would match the first line and it would still have the alarming, because the first match is the one that wins, and it would never get to the second line. So you need to make sure that your SL log is on top, and all the other processes don't start with SL log, so they will be matching the second row. Okay, so that's how it works on defining those alarm thresholds with tables. So you activate it on a column, and then you can further tailor it down with filtering on specific items, multiple filters, or more restrictive filters. Then the order needs to be well defined and correctly defined in there. Okay, so let's go back to our slides. So we did a little bit of another exercise with the task manager here. We defined some filters, we defined a little order, and we played around with those thresholds. So that's dynamic tables. The monitoring is applied top to bottom. An important one, because tables are frequently used, as I mentioned. So that's important. The next thing is a little bit more a special condition, or special element, you could say. We do have that special control for matrices, where we do have a series of inputs and a series of outputs, and we can make cross points there. So every cross point, we can define our alarming on there, and we can say like, yeah, those are the normal connections, and we can define, oh, if input 3 is connected to output 2, then we have a little warning alarm here that maybe we're running on, like, for instance, a backup, you could say. And in this case, we also have an alarming on the input 2, that input 2 is currently generating a critical alarm because nothing is connected to that. That's not good. If nothing is connected to that, we have a condition where we want to notify the operator. How does that work to define that? We'll see that it doesn't fit into those columns. So therefore you have in those columns just a special button that opens up the special control to make all the necessary thresholds in there in that special editor. I'll just have a quick look at a demo here. Let's go back to our training system and let's close what we have. And let's go for an example that we have here, the matrix alarms. So here we have the matrix and we see that there are certain alarm thresholds defined on there, and there are alarms being generated on this special matrix control. Well, if we right click, I'm doing a little shortcut to reach that specific alarm template to open it up. Instead of going to the protocols and templates app, search for that specific driver or connector and search for the correct alarm template. I can just right click on the element, go again to that protocols and templates, and then view the alarm template. It's one of the first, second item there, view the alarm template. And it immediately loads me that alarm template so that I can have it next to it. So there are a couple of other parameters on the general page with PSU, power supply parameters and things like that. But I'm not worried about those regular parameters. We already covered those previously. But that special control there, that matrix control, has that button that opens up that special control to configure everything. It's a little bit similar as you could say the data display, the data display there. So, but I can select a specific cross point and I can define which alarm color I want to associate with it. So I just select one and I specify on the right hand side which alarm level is associated with that. I can also do just select, drag and click and drag to have like a whole region being selected, and then activate the alarming with it. And if you want to remove it again, so you can just select it and put no monitoring on there, which is the default, of course. So that is just, there is also information. I'll talk about information alarms later on. So every cross point can be selected and associated with an alarm level, but also the one here, input 2, then you need to select go to the selection mode inputs, and then I can select this one, and I can maybe change it to critical, for instance, to match the one from the slides. So if that input is not going to be connected to anything, then it will generate a critical alarm or major or whatever you select on the right hand side. So that's the editor that is available in your alarm template. I think that's sufficient. And you will see if I select this one, the alarm will go away on the inputs too. Yeah, now it's connected to something. So that alarm just disappeared. Okay, so that's for the alarm definitions that we can do on a matrix or a router control. What else do we have that we want to take a look at? Now, I mentioned that information option we have there. Well, under certain circumstances, you don't really want to generate an alarm, because an alarm kind of like immediately worries the people managing the system. The operator will immediately see in the alarm console, oh, even if it's a warning, there's still an alarm. And you might still set off certain people to be worried about this warning alarm. Well, then you don't want to generate anything, also fine, of course. But sometimes you want an alarm to trigger something in a system, to trigger, for instance, a notification to somebody, or to trigger a correlation rule, or just to have audit trailing. Also, with audit trailing, you could, of course, activate trending, but maybe if you want to trigger a correlation rule, then you might want to generate just an information alarm. So instead of a real alarm, it's more an information alarm, or actually we call it information events. So those information events, that's like the audit trailing. If somebody logs in, if somebody changes a parameter or configures something or creates a new alarm template, all of these things are being tracked in the audit trailing or information events. While you can also say, for instance, if your level, it's like an audio output level, for instance, is getting a little bit higher or lower, each time it reaches a certain threshold, if it goes escalates above a certain threshold or drops below a certain threshold, like we defined here. We defined an information alarm with 6, so then it will generate an alarm whenever it reaches 6 or if it crosses above or below. Same thing for an LMB1 supply, and on-off, each time we have the value off, it will generate an alarm. Let's have a quick look at the example. So we have one element which is already configured for us with such a threshold. Let's take a look at that. We right-click on the element. We go to Protocols and Templates to view the existing alarm template that has been configured for us here already as a little example. Let's maybe quickly remove the included for now. Let me maximize that for a moment. You will see that here indeed, there is no monitoring enabled. So you can see there is no checkbox, nothing is enabled in the monitoring. Okay, so no alarming will be generated. You can combine it. It's just as an example that this is not activated here for now, but you can still activate it. And here it says like, okay, it will generate an alarm whenever my audio output level escalates above or drops below 6. And also the audio mode will generate some information event with test tone, for instance. Let's play around with that. Let's open up the information events, and let's now play around with this new with this audio output level. It's currently 3, so if we escalate above 6, we go to 12 for instance, you will see that an escalated above 6 is now generated. If we go back, it will also be a dropped that is being generated. And the same thing we had for the audio mode. If we go and toggle that between impeg and test tone, then it will of course generate those associated values. Note, of course, you see now my set is in between there as well, because I manually trigger and manipulate those values like an audio output level. But if we would be talking about a value which is configured or which is a reading, then of course I would not have those sets. And I can basically remove those sets. Maybe that's a little trick I didn't show before. I do a control click on BERT to have everything filtered on BERT, but I want to do a negative filter. I think I forgot about showing you negative filters. Then I need to say exclamation mark BERT. So now everything with BERT is being removed. So now I can see that my audio output level was escalated above and then dropped below. And then we have my audio mode, which has the two values there. So that's sorry, I had the video in front of me. So let's just, I did here a filter, a quick filter with exclamation mark BERT. That's how I added it. I clicked on BERT to have BERT in there, and then I added an exclamation mark before my first name to filter that out. All right, so that's generating an information event which can still be picked up by correlation, for instance, or by notifications, and it doesn't worry the operator that there is an alarm condition. A little bit of special case, but nevertheless, it could come in handy. Now, A very important one and a often frequently used one is hysteresis. And that's an important one because there is nothing more annoying than having like toggling alarms. If it's like a signal level that is continuously increasing, or if it's like a CPU load which is continuously changing a little bit, you might have something like, oh, there is an alarm, no alarm, alarm, no alarm. Especially if you have like a CPU load, it goes high, it immediately generates alarm. A couple of seconds later, it's again low, so the alarm disappears again. So that's annoying when using the system, that you have these kind of like false alarms. So what can you do? A typical thing is using that hysteresis. Hysteresis is nothing more than defining a delay on the generation of the alarms or the clearing of the alarms. So the first thing that I can maybe explain is the on-hysteresis. The on-hysteresis, that means that you could say I define a delay. In this case, it says 60. You define a delay on the generation of your alarm when the alarm is on, when the alarm is there. And that's typically, a typical use case is CPU load. It's normal that my CPU load goes to 90 or 100%. I mean, the CPU is there to be used. But I don't want it to be continuously on 100%. So how can I do that? Well, I can say, well, if it goes for a second or a couple of seconds to 100% or above 90%, that's okay, as long as it goes back. But if it, in this case here, if it goes 60 seconds to 100%, then I start worrying. Or maybe 60, or maybe a couple of minutes or 5 minutes or whatever. You can define whatever in there in terms of a number of seconds. So you can define if my CPU load is too high for a couple of minutes, then only then I generate an alarm and I start to ask the attention of the operator to take a look at this. The off hysteresis is defining a delay on when the alarm should be cleared. And that's the example we have here at the bottom. Over time, my signal level is increasing and decreasing. So my signal level is suddenly getting a little bit too high, and therefore I go into that critical zone and I start to generate a critical alarm in my system. But yeah, that signal level is very slowly increasing or decreasing. So sometimes it toggles a little bit between one and the other. So it means if it's only going back for a very short period of time, I don't clear the alarm yet. The alarm remains there, and and if it goes back into critical, yeah, it was still there, but only if the parameter goes back into a normal value and goes below the threshold, in this case, for a longer period of time, in this case 30 seconds, the off hysteresis is 30 seconds. If it's off for 30 seconds, then I clear my alarm and I go back to the normal situation. So you have two hysteresises, two delays you can define when you generate the alarm and when you clear the alarm. I'll play around with that in a demo. Just for you to be aware of that, there is a little bit more complication added to this setting, because you can define the on hysteresis only on certain thresholds. For instance, only on criticals I define a hysteresis, and also for the off hysteresis you can define that only the off hysteresis is applicable for certain thresholds. That is also visualized with the small line. So the on hysteresis is defined at the bottom. So these ones are in the higher ranges. We defined a on hysteresis. So there is a line defined here at the bottom. The off hysteresis is in the second one, is defined on the lower ranges. We'll play with that here in the UI as well and take a look at that. So for the hysteresis, I do have an example here, a hysteresis alarm that is already activated on this element. But let's take a look at that because I first want to investigate what has been configured. So I right click on the element, I go to protocols and templates, and I say view the alarm template. And the alarm template is called hysteresis training hysteresis. Let me remove that included, excluded again. Let's first maximize it and let's take a look at that. So what has been defined? Well, the on and the off hysteresis is both 10 seconds. So all of the ranges are being delayed with 10 seconds. Let's maybe just start with an on hysteresis of 10 seconds first of all. So that means now the only thing I configured and I applied it, I saved it. I defined on my audio output level a on hysteresis of 10 seconds. So let me open up the active alarms, or let's maybe do a little trick and add the hysteresis element. I just drag and drop my hysteresis element into the alarm console and I say show the alarms so that I see all the alarms of my hysteresis element. Then I can play it a little bit without seeing the other alarms. So let's play around with that and let's generate or let's force a parameter into alarm. We will see it will go into the alarm and then it will like wait 10 seconds before it will effectively go into alarm. So I have no alarms at my alarm console until now. I have my alarm that pops up there at the bottom. So it took 10 seconds before it was generating the alarm. If I clear it, it will immediately disappear again from the UI. So that means if I have like a CPU load, it quickly goes to like 100% or now in this case only 18. As long as I go back to a normal value within that 10 seconds, it never generated an alarm. So I can quickly go back and forward like small spikes. That's allowed because I have a delay of 10 seconds. So I can also define a delay of 10 seconds on the off hysteresis. Let's apply that one. So let's go once more to 18. So it will again take 10 seconds before my alarm is being generated and the alarm is there. And then once it's there, it will be kind of like locked in, you could say, because the alarm will now stay there, even if for a short period of time it goes to 12, which is a green region, it will remain in red, the alarm remains there. So that might be confusing. It quickly goes back, so it never disappeared. So it might be confusing if you see that the value is still red and has an alarm while it is in a green zone. Well, think about that hysteresis. So only if it goes back to 6 for a longer period of time, and again we're going for that 10 seconds as we defined, it will only disappear again after 10 seconds where it will disappear now. Okay. You can of course play now also with defining that the on hysteresis should be on certain thresholds, for instance only on the low or the high. For instance, only on the on hysteresis is only on the high, and this one only on the low, like that. For instance, so there you can see that where those are being defined. So that's to make it a little bit more granular where you want to define those thresholds or the delay on that alarm generation or that alarm clearing. As I said, very important, for instance, like a CPU load, typically in on hysteresis, if it's a level, a receive level, typically an off hysteresis, because you immediately want to pick up on the alarm, but the clearing of the alarm only disappears when it goes to a good value again for a longer period of time. That will avoid toggling of alarms. So if you have those toggling of alarms, think about that hysteresis. Note there is a small indication there that the polling interval of that parameter is longer than 10 seconds. So it doesn't really make sense to make it only 10 seconds. So therefore it gives that little rectangle around it to indicate that your polling interval is actually higher. So you should also increase your delay, but this is only a demo purpose, of course. Okay, hysteresis, a very interesting one to avoid toggling of alarms and avoid that clutter in your alarm console. Okay, another one which is a little bit more to allow reusability of alarm templates, because like a CPU load, for instance, a total processor load, yeah, I have servers, and some of my servers are running high in CPU load and some of them are running low, or I have different receive levels of different the signals coming in. So do I need to make an alarm template for each and every level then? Well, if you want to have them tight, well, you can have them wider than and have one generic alarm template for all your receive levels or all your processor loads. But sometimes, yeah, you want to have them a little bit more tight around the normal expected value, and just have only a little deviation allowed from that expected receive level. Well, therefore you can use normalization. And normalization means that you normalize each and every element. So if you have like 5 receivers, you can define one alarm template and say, well, the first device has like a high receive level, the second one a medium, and the third one a lower. And I define in my alarm template only a deviation or a delta from the normal expected value. And in this case, the normal expected value, I can click on there and I can define for my 3 elements that I have here what the normal expected baseline value is. So we have a baseline value per element that we define, and one element is expecting, in this case it's CPU load, 5%, the other one 15, and the other one 50. And if it goes 15 above that normal expected value, then I generate an alarm. So your alarm range is basically moving along with you as you define that baseline there. Now, to make it a little bit more complicated, we actually have 2 types, well, 3 types, but I'll consider the rate a special one. We have 2 types of those normalizations that we want to define. First of all, this type drop-down is typically just on normal. That's the regular normal alarm thresholds that we defined before. But now we will take a look at those normalized alarm thresholds, which could be relative or absolute. If you go for relative, then the relative means that it is defined, your delta is defined in a percentage. If you go for absolute, then your delta is defined in the units that are specific for your parameter. In this case, it's a bad example because it's percentage again, but we'll take a look at the UI as well. So that's the only difference between relative and absolute. That means that your deviation is defined in the actual units. If it would be dBm, you say 3 dBm, or if you say in percentage, 10% more, for instance, than the normal value. Then the higher the value, normal value is, the higher your percentage or your real deviation will be as well. So you choose your normalization type, relative or absolute. You define your thresholds or your deltas there against the baseline, and the baseline can be defined by clicking on there and specifying that with the editing on your different elements using that template. Now, to make it a little bit more interesting, we do also have here at bullet point 4 the automatically update baselines. So you could actually say to the DataMiner system, well, I don't really want to configure all those normal expected values. If that's 3 elements, okay, that's still doable. But if I like have hundreds of them, I don't want to specify all of them. You actually figured it out, and you go and automatically update those baselines. And you can say like, oh, you just take a look at the trend window of last 7 days, and you take from the last 7 days what average value you have there. Well, to be correct, it's not using the average, but it's using a median. So it's taking a look at the last 7 days and says like, okay, that's the normal expected value based on those last 7 days. There is a possibility also, so you can define that 7 days, but you can also skip the last X hours, and that's to make sure that, for instance, if a signal is slowly degrading, that your average or median is not following automatically. And you would not notice that. Therefore, you could skip the last 24 hours that you can say, I'm looking a little bit at a further history to know my normal expected value. Now, there is also the possibility, and that's also an interesting one, where humans can have impact on the parameters, which could have like a daily pattern. People are getting up in the morning, so you start using more traffic and then go back to bed in the evening, so it slows down again in the evening. So during day and night, you have this typical day-night behavior of certain parameters. So therefore, you could also say, instead of a continuous degradation that I want to detect, I also want to you can also go for that expected daily pattern. And you can say, like, look at the last 7 days. Again, you can skip the last 24 hours. You could optionally handle the weekend days separately. So you can say weekdays and weekend days are handled separately, or just every day is the same. And then it will look, and it will look at every 15-minute slice of the day. And every 15 minutes of the day, it will take a look like what was it yesterday and the day before and the last 7 days, and take the average or the median value of that 15-minute slot. So if you take a look at the time now, it will go from the hour until 15 after the hour, and take that 15-minute window and take a look at it, what it was expected during the last 7 days we had in there. So the 24 hours of a day are split up in 15-minute slices, and for every 15 minutes, it will keep track of what the normal expected value is. So it will continuously, after every 15 minutes, it will adapt the baseline to be what the expected value is, and go up and go down again in the evening to follow. And you can really have tight alarm templates that are tight thresholds, deltas that you define around that normal expected value that changes during the daytime. So that's also an interesting option. So the first one is more for continuous values, like a receive level, and it learns it from the history. The second one is more for a daily pattern, and it learns it from that slice of the day, that time, that 15-minute time slot of the day from the previous 7 days in this case. Okay. We're not going to go into that much detail of automatically updating it. We'll play around with just the manual updating and see how that behaves, and then see how it behaves against that delta. Okay, let's take a look at that, because we do have also an example on that one. Let's close our previous example. So we have two normalization alarms, alarm elements. Let's open them next to each other, open a new card, and let's open up the data display. So we do have those new two elements side by side. And just to show you, let's go to the edit, and let's go to the edit of this one. They are both using the same alarm template, training normalization, and still, let me cancel that again. You can see that this one is 18 and it's all green. This one is 6, it's all green. And actually, if this one would be in 18, it would be an alarm. So you can see that the normal expected value of those two is apparently already different. So they are expecting two different values, but they are using the same alarm template. Let's check that out, how that works. So we right click on one of the two, it's the same alarm template, go to protocols and templates and view the alarm template training normalization. Let's open that up and take a look at what we have configured there. I'll just remove that alarm, exclude. So we have just activated, or it has activated only on one parameter, the audio output level. We don't really need to worry about the other parameters. If you want, you can of course show them there and show all of the parameters, but they are all disabled. That's why they are not showing up by default. So we only go for that audio output level. Instead of, by default, this has always been normal, but instead of being normal thresholds, they are the normalized parameters, which normalized thresholds, which are relative or absolute. In this case, it's absolute, meaning it's in the units that we have here, dBm. So it's defined here, 3 dBm more or less compared to the baseline value. The normal expected value will generate a warning alarm. And you could, for instance, say, let's add 6 in there. So if we go for 6 there and there, you will see the delta 6. The delta is automatically added. So if you click on the editor, it's only 6. So delta 6, 6 dBm more, we're talking in dBm here in this line, 6 dBm more or less will be generating an alarm. And what is that baseline or that base? Let me maybe just apply our 6 because we changed it now. We only had previously a warning. Let's apply our new change here and see that this indeed works indeed. So 3 more is warning, 6 more is critical. So also here, yeah, on the higher side, we are already to the edge of the maximum possible value. But on the lower side, we can still see the 6 dBm. Okay, so now what is also there, that baseline? What is that normal expected value? So we cannot change the normal value. Previously with the normal thresholds, we were able to change that. Well, the normal baseline, the normal value is if you click on it, you see all of your elements currently using that specific alarm template, and you can see the current value, and you can define the baseline. The current value is there because if you have like 10 receivers, and then you can see like, oh yeah, this one has a little bit higher one, let's put it on 18. This one has a little bit lower, let's put it on 6. And actually you can also use the current value here in the right click menu. You can use the current value as the baseline. And there's also one set the baseline to the current value if the baseline is value is defined. So you can just take basically that current value. Let's play around with that. So if you put it on 12, so you can manually change it. Let's put it both on 12, and maybe I want to see it over there as well. So this one is now on 12 and this one is on 12 as well. So as soon as I change this, this immediately changes. Let's put the first one, which is 6, is this one here, is now going to 6 automatically. This one is still on 12. So if you want to say like, I have a lot of these elements, and this list is very long with all the elements in here. I don't want to manually define all those baselines. Well, then you can just right click on there and say use the current value as baseline, and it immediately copies the 18 over there and the 6 over there. And then all of your elements will go into normal alarm, because you say that the current situation is the normal situation. So currently all my receive levels are okay, everything is working fine. So I kind of like take a snapshot and say like right click, use the current value as the baseline. That's all good. If from now onwards my value is suddenly changing here and it's going to 9 and it starts to increase, then it will detect because it's 3 dBm more than my normal expected value, because I defined here that 3 dBm more or less compared to the baseline. Okay, so that's how I can define that. Let me maybe move that to a layout with a top on master and put this one over there. I should have done that maybe immediately. That would have been more easy to work with. Okay, so that's how I define a absolute threshold and define my normal expected values. Let's maybe put this one back on 6, that we have again a normal situation. All okay. Instead of doing the absolute delta in the dBm, we could also go for relative. Then it's 3% more, which would be very, very minor. So let's maybe put it on 10% and here on 20. This is, of course, again, an invalid limit that is defined here, the 6, because it's lower than 10. It should always increase on that side and always on this side as well. And 10 over there and 20 over there. Apply. So now the 6 is yeah, 10% more is still not that great, but let's take 50%. That's maybe more, and 75. So if I take 50%, it will be more clear, I guess. Because then it will also depend on if your value is 6, then 50% more is 3 more, is 9. But here, the 18 is, yeah, maybe 50% less here, is 50% is 9 less. So you can see the higher your value is, the higher your delta will be as well, because we're talking in percentage. 50% of 18 or 50% of 6 is, of course, a big difference. So it depends a little bit on which kind of normalization you want, that you can play around with that. Okay, let's put it quickly back to 3, because I do want to do another example, and that's the last one, which is in this drop down. That's the rate. What is the rate? The rate alarm is allowing you to define a change of the if your alarm is rapidly changing between 2 pulse cycles. You can see, or you can hardly see, that there is a rate in there, not so visible, but this is now fixed. I can no longer click on there and define the normal expected baseline there, the normal expected value, or the baseline. Well, what is the baseline now? Well, the baseline is the current value. So it means if I go 3 dB less or more, what will happen? It goes into alarm. Let me go into alarm, 9. Okay, I go to 9, it goes into warning. But what will happen is that the next pulse cycle, it is again considered as normal. So you only generate an alarm when you quickly increase. Let's maybe do it like that. Let's remove the 3. And apply. So you can say now, you can see that we have a bigger range, which is normal, and my audio output level, I only expect it to have slow increases or decreases. So it can go from 9 to 12 without any problem, and then the thresholds will immediately adapt, and I can go to 15, and the thresholds will adapt, and I can go to, well, let's go to 15, there it is, 18, so you can slowly increase and no problem, it remains green. And I can go back to the left hand side as well, as long as I do that more slowly and not too fast. There's no big rate change detected here, so my alarm thresholds are immediately progressing along with me, and I allow these kind of subtle changes. But as soon as one of those parameters is doing a quick change and I suddenly have a quick increase, then I want to generate an alarm. Let's say it's 9 and it now in one go goes to 15 or 18 into the critical zone, then it will generate a critical alarm, a short critical alarm. The critical alarm is there now. There it is, the critical alarm. Oh, and let me just do that again, because I was not on the correct element on this one. Or let's go just to a big change, lower side. Yeah, I was not fast enough and it was now on 9. So let's go to 9. Back to the normal situation, and I go to 15. If I generate the alarm 15, you will see now the 15 was there for a very short period of time. It was only there for a very short period of time. Not sure if you missed it. You can go back in time with the video here. But it was there for a very short period of time, because the next pulse cycle, my alarm thresholds all are already moved. So this type of alarm, a rate alarm, is a very short-living alarm. And typically you would need to pick it up with correlation to make it more persistent. But it is able to trigger something and to detect something that there is a quick increase or decrease on a parameter. That is what the rate is about. But let's just put it back on the absolute, which is the default here. Okay. So that's the normalization I can do. Typically, the most common thing is absolute normalization, and I can use that for elements that have, for instance, a higher expected value and elements that have a lower expected value, and they can still have quite tight thresholds, and depending on which one, you will have different normal values defined in the baseline. And remember, optionally, those baselines can also be automatically updated by the DataMiner system based on the history of that parameter. Okay, so that was normalization, a very useful feature to more make sure that one alarm template can be used for a whole series of elements, even if the normal expected value is different, and also to use it with more automatically updating baselines, even with a daily pattern. Because then a subtle change during the night or during the day or in the middle of the day will also be picked up, and you don't have to have very wide thresholds to capture the whole like kind of sinus curves in that trending or in that parameter. Normalization, a very powerful feature there. This is the example that we have here with a total processor load. So you can see that we have three elements. They use the same alarm template, but still you will see that this one has a lower normal expected value. This one has a higher 50 and this one has 15. So they all have their own normal expected value. So the thresholds are adapting to what is normal expected for that specific server or element or any kind of device we're talking about. Normalization. The next that I want to specify, so we already took a look at a lot of the columns there. So we took a look at the checkbox in front of it, the type, all the regular columns there, the hysteresis, the info, and now we have some more columns on the very right hand side. The first one I want to mention here briefly, because we already touched upon that during the alarm console as well. Normally, when alarm happens, it's open in the DataMiner system, and when DataMiner no longer detects the alarm condition on the actual data source, it will automatically go to cleared. But if for one or another reason you want to make sure that every single alarm that happens on that specific parameter must be verified by somebody, then you could put it not immediately on cleared, but on clearable. Clearable is an intermediate state. DataMiner then puts it on clearable. It remains in the DataMiner system in the alarm console as a green alarm until somebody picks it up and says like, oh, we just went for a coffee, or we had a coffee break and we came back. Apparently something happened because there's still some remaining green alarm here. It quickly came up and down. Nobody saw it when it came up, but we still have the proof that it happened. I can verify certain things and then say like, okay, we looked at it, we verified, it's back okay, so we can clear it. We've done the necessary actions. That's something you can activate system-wide, but to activate it system-wide, then it happens on every alarm. Sometimes you just want it like on like a receive level, for instance, or in this case, it's here on the total processor load. On the very right-hand side, you can have an additional column that is being added, auto clear. That's activated, that extra column. By default, it's hidden, not to clutter the UI. So you click on the cogwheel there, or the different wheels there, to allow an override on the auto clear, and then you can define that auto clear yes or no and have that feature activated. We do have a quick example on that, so let's close again everything that we had open so far, and let's go for that auto clear. We have two parameters on here. Let's investigate the alarm template by right-clicking on the element, going to Protocols and Templates, and go to View Alarm Templates. So if we view the alarm template, we will see we only have two parameters. That's fine. Those two parameters, they are both activated for monitoring, and on the very right hand side, this allow override of parameter auto clear, this extra column has been activated. We can see the second one is the default, which means that if it goes into alarm, it will also clear again. And the top one, I'm both forcing them into alarm in meantime, is not going to do an auto clear. This one is not auto clearing the dummy number one. So let's try that out. So we both have them in alarm. Let's now both force them back to 0, which is the normal value. And I can see that my dummy number 1 remains in there and my dummy number 2 is gone. Dummy number 2, that's the default behavior. The alarm is gone. We remove it. Nobody has to worry about it anymore. But we say like, oh, this first one, don't clear it just like that. I want somebody to take a closer look at it because that green alarm, we can still investigate. Oh, it went to 20. When did it happen? How long did it happen? We can still do some investigation and then say like, okay, we're happy with what the situation is now, and we can now clear it by right-clicking on the alarm and go for that clear alarm. Now I can also add a comment there or a motivation for my clear action. I clear the alarm. Now it's gone and it's removed and nobody has to worry about it anymore. So typically done more for special parameters that every alarm needs to be investigated a little bit more in depth. The auto clear. Another extra column that is in there is for analytics. So we already saw that the analytics is continuously looking at your system to investigate how the parameters are behaving. And whenever some anomalies are being detected, it will generate some suggestion events. So here we can see in the alarm console some example suggestions that are being generated for flat lines, for variance changes, a level increase, an outlier can be detected. All these kind of different suggestions can be generated. Those suggestions are being generated by default by the system. But if you like any of those suggestions, you can actually say like, oh, well, actually, if you detect that one, I want it to be a real alarm. And some of those anomalies are actually very interesting because just to name an obvious one, a flatline detection. Flatline detection is impossible with regular thresholds. I cannot say, well, my bitrate, it should be higher or lower than a certain value. Well, I can do that, but then my 2 megabit is still between those two values. But if it always changes a little bit, my variable bitrate. But if it suddenly flatlines, yeah, that doesn't go above or below a certain threshold. It just flatlines, the behavior changes. Well, that kind of thing is something that the anomaly, the AI guys can detect, and they can detect a flatline and they will generate by default a suggestion event. But if they detect this on a parameter where you activated this option here in the analytics pop-up, then it will generate a real alarm in your DataMiner system. So they help out by generating alarms on these kind of difficult to detect parameters. But also could come in handy when, for instance, a trend is changing, a variance, an outlier, a level shift, all of these things can be configured in there. We don't really have an example on this one configured here in the example, but we do have one in our system. So if we, you can add a plus sign, click on the plus sign and go for suggestions, or remember you have that light bulb, and there you can also see some anomalies detected. We can actually see that there are some level decreases and trend decreases and all kinds of things, which are the gray ones, the information events, but there are some of them which are actually a real alarm. And that is because if I close these cards and if I go to my server, that Microsoft Server 01, and if I, you can also, instead of right-clicking to each time to open up the alarm template, I will go through the edit in this case. So I go to the edit of my Microsoft server, you can see that a standard alarm template is being used, and there is an icon next to that to open it up. So if you click on there, you can also easily access that element, your template. And what will we see if we make it a little bit smaller? We can see that indeed the analytics column, by default, it's disabled, but we do have some of them which are customized. And if you click on there, you will see that some of them are being activated. So you can activate each and every one of them with level. Yeah, you can play around with that. Level increases or decreases. Then you can also say smart, relative, absolute. Some more options are available to that. You can find more details also in the help. I'm not going to go into too much detail on those, but you can see those ones were activated and therefore they were generating some alarms. Note that the alarm level, if it's a critical or a minor in this case, is also defined by the analytics module. So if it's a big increase or a small increase, they will associate in a certain alarm threshold level with that. So that could come in handy for more automatic detection of alarm thresholds, and the AI helping you out a little bit by detecting certain anomalies that are unexpected. So it looks at the normal expected behavior of your parameter, and then if something abnormal is being detected, it will generate an information event or even an alarm if you are activating those options here. Okay, so that's the anomaly, and the another option which is more in the header, a little side note here, is the scheduling, template scheduling. I can define also a schedule for when my alarm template is active or not active. Not that frequently used, but I just want to mention it. If I quickly go to any of my alarm templates of my training element, for instance, I do have this header section that is by default collapsed. In the screenshot it was open, but so you need to first click on show the details. So you can hide and show details. It has some generics, some generic details there. But what we are talking about here is the scheduling part. By default, scheduling is not active, and it will always be active, your alarm template. But you can configure it to say like, okay, instead of always being active, my template, it is only active during a certain schedule. And you can define, for instance, only the weekend days it is active at starting at a certain hour until a certain end hour. So for instance, if this channel or this source is only being active for a certain period of time during the day, only during prime time, for instance, or only in the weekends or whatever, you can activate certain timings where these alarms need to be generated, or when that monitoring needs to be active. Outside of those windows, it won't do any alarming. You can play around with that as just a timing thing. Just be aware, whenever it's outside of those windows, for instance, here in this case, it's only active Saturday, Sunday from 8 till midnight. If it's outside during the weekdays, for instance, there is no monitoring at all. If you want to have during the weekdays, for instance, a different alarm template being active because you still want some other monitoring or some base monitoring that the equipment is still functional, and that not on Saturday you suddenly notice that your device died during the week, then you might need to look at more scheduling, a task scheduler that is changing your templates with some automation scripts. That is possible as well, but not baked into that header bar here. The header bar is just a plain simple activate, deactivate. What is possible, and that's what I also wanted to mention, is we'll look at the alarm template grouping. If you have groups that are stacked on each of alarm templates which are stacked on each on top of each other, then you can actually say that one template is no longer active, and then it will fall back on the ones that are below it. So then the scheduling could still come in handy to have a base to fall to as outside of the windows there. We'll come back to the alarm template grouping later on. Okay, one more column that I need to cover is that condition. Conditional monitoring allows you to say like, okay, well, I want to have monitoring on my audio output level, but it only makes sense if, for instance, there is an actual feed coming into that device or into that system. Because sometimes, yeah, if the input of that system doesn't receive the feed, well, then you could generate a gazillion alarms on there, but because the input will be down and some processing parameters will all go into alarm, and you have like kind of like almost an alarm storm. Whenever the input goes away, there's like a whole bunch of things going into alarm. Well, you can avoid that by making conditional monitoring and say like, yeah, I will always, for instance, monitor my inputs. But if my input is not there and the signal is not coming in, then it does make sense to monitor the other parameters. So the other parameters are actually being disabled when that input is not there. So that's what you can do with conditional monitoring. So you can say like my audio output level is only being monitored under certain conditions. And this is important to understand how this works. The parameter will be excluded if the condition is true. So it means that it disables the monitoring if the condition is true. So if this LNB supply is off, it turns off the monitoring on the audio output level. So if the signal is off, the signal is gone here, for instance, on this parameter, then it doesn't make sense to monitor that anymore. And you can say like, don't worry about it. If there is no LNB supply, then it doesn't matter about that parameter anymore. It avoids to have, instead of 10 alarms for the operator, to only have one meaningful alarm. Let's take a look at that in an example. So let's go to our conditional alarm element here, and we do have some parameters on here that this one is in alarm and some are not. So let's take a look at what is configured here. So once more, I right click on the element, go to protocols and templates, and I go to the view alarm template. So the alarm template that I have is the training conditional. So the title already says it. There is some conditional monitoring, and apparently there is some monitoring being done, as I already saw, on the audio output level, but apparently there is a condition. And the condition is, if I maybe just remove that one, make it a little bit bigger by doing this, and then make this bigger, then I can see it's actually going to disable when the LNB1 supply is off. Oh, let's check that out. The LNB1 supply is actually on the other page, the modulator. Let's LNB1 supply here. It is indeed on. So let's turn that off, and let's go back to the audio page, and indeed, now it's gone. It's no longer monitoring. So it's no longer going to do any alarming on this parameter as soon as the LNB1 supply is no longer on. So if I put it back on, this one is again immediately monitoring. So let's take a look at that. So the audio output level, we just defined the regular thresholds as we always did, but we defined a condition on there. And if we click on the pencil icon, we can see a condition is defined by the name. We try to make sure that we have a usable or meaningful descriptive name there. Disable when LNB1 supply is off. And indeed, LNB1 supply equals to value off. So this is just drop downs. You can select a parameter, a value equals to, not equals to, these kind of things, to the value of, and we can just add more of them as well. With an and or combination, we can add more of them. This is a simple one. Whenever the LMB1 supply is off, it will disable the whole row as we just played around with. So as I said, this is very meaningful. For instance, if an input goes into error or into an alarm state, then we only want to have this alarm, and all the other consequence alarms, we want to disable them. That's typically how we want to improve our alarming with this conditional monitoring feature. Useful feature to have correct and meaningful alarms to get immediately to the point what the actual problem is and avoid clutter. All right, so here we do see the example. On the left-hand side, we do see the on and then it's active. If we turn it off, it's no longer active, the monitoring on the audio output level. We've played around with that one. Remember, as with the trend templates, we can drill down into a certain parameter and immediately see the alarm template changes. So if I go and take a look at my audio output level and you want to change certain thresholds, remember, just double click on your parameter. It goes by default to our trending, but we have that templates page there, and there we can see the thresholds. We can tweak it. We can just click in there, change that 15 to something else, or define a major range, or define everything we just defined. Remember, there are two ways of changing it, only for this element or for all the elements. This is maybe not the perfect example because only one element is using it. But if I go for this one and go to the audio output level of this one and go to templates, what I'm doing is I'm going to an alarm template which is being used by more than one element. Then if I change any of the settings here, this one is with delta, you will see that actually the normalization element 1, I'm on normalization element 2, the 1 is also using the same alarm template. So if I'm changing any of those thresholds here, this will also impact this other elements or the series of other elements that are in there. So if I click on update alarm template, whenever I do a change, then it will change or has impact on all of those elements. If I don't want that and I want to modify only this element that I have open, then I can say update this element only, and it will suggest me to make a copy of that template and only apply it to that element. But then I start creating copies of alarm templates, and the same thing for trend templates. And I want to make sure always that I try to have not too many templates just to keep it manageable. So I rather use the features to make sure that they can reuse them across different elements. But be aware, if you quickly want to change something, double click, go to the templates, make your changes without even going to the full alarm template. You can do it. There's also a convenient edit from template. If you still want to see other things, click on the edit from template and it opens up the full template editor again. Okay, quick editing, so it makes sure that it's always close by to quickly change something, because it is important to continuously evaluate your thresholds and improve them to make sure you have good alarming, as I already mentioned before. Now, assigning the alarm template, that is kind of already what we did. Also in the editor or in the protocols and templates app itself, if you select a certain alarm template, you do have on the right hand side the possibility to assign it immediately to one or more elements and use the pop-up. Click on the button or click on the right click to reach that pop-up and give it or assign it to one or more of your elements that can use this template. We already assigned it. You can also do it during the edit of your element, so we already know how that works. Now, one last feature that I need to discuss in here is the alarm template groups. The alarm template groups allows you to take multiple alarm templates and group them together. Now, why is that interesting? Well, that is interesting because typically you might want to create a base template for all of your devices. And typically you will include all of the parameters in there and say like, yeah, that's typically what I want for the regular default server or switch or satellite receiver or whatever you have, a cloud encoding function, whatever you have there, that's my defaults that I define. So that's a good starting point. One base for all. But of course you will have deviations and exceptions and etc. etc. So instead of making for one single small exception a bitrate that needs to be a little bit higher on one of your elements, instead of creating a full duplicate of your complete alarm template with all of the parameters being duplicated for just changing one single parameter, then if you do lots of these actions, if you need to manage all of those templates, then it becomes difficult. Therefore, a base could be coming in handy where the base remains there and I will add an overlay on top of that with only one single parameter in there which is different, or a couple of them. So that's the purpose of creating groups. So in this case, I create first a base and I can define all the parameters that I want in there, and I can find all the thresholds in there. Note that there is a special column now I can add by clicking on that the cogwheel icons there. That's allow the inclusion and exclusion. For your base, it doesn't really matter that much because they are basically included, you could say, but just as to be complete, we say that everything needs to be included here on the base. I define the base. And now, secondly, I will create an overlay, you could say, something I put on top of my base. And that's more for one specific special case, more the exception, you could say, that I want to create something different. And there on that overlay, in this case for web servers, I create an overlay and I only define limited number of parameters in there to do special alarm thresholds on those. So only those will be more exceptionally treated. And then I can put that one on top of it and I remain my base underneath it. For manageable reasons, or for manageability, that is quite convenient. Now, how do I add those two on top of each other? Well, we already saw if we right-click on any of the alarm templates and created a new alarm template, we did have the option to create an alarm template group. So if we take a look at that, how does that work? Well, you will see that you have here just on the top, it's very simple, an alarm template group, because you can only include existing alarm templates and define the order again from top to bottom it will be applied. So you can just add, in this case, two of those available templates were added in here, the base at the bottom and a web on top of it. And the result is being shown here. Now, if we take a look at what has been configured, if we go back to the previous slides, in the base, we had the total processes that are being added in there. And in the overlay, we disabled the total processes from that overlay while it is included. Therefore, it is not showing the total processes in here. So the total processes is no longer in there because we kicked it out of the overlay. I'll also show you here an example. Or I will create an example maybe because I believe there is an example in here. No, there is no example in here. So let's create a quick example by going to our alarm templates. And what we will do is we'll create a quick example on our Microsoft I can just type in the first column Microsoft Platform. I select Microsoft Platform, Production, and I have some of those alarm templates available here. I have an example that is here available with a base. A base, let's open it up. The base has already quite a lot of parameters in there. You could say it will monitor the disk, the network interfaces, total threads, process load, etc., etc., and also physical memory usage with 90% there. Okay, that's good. That typically I can use those this alarm template. But now if I say like, yeah, but there is one case or a couple of those servers which actually go to 95% memory usage. Yeah, I could change this one to match 90 or maybe 99% before the alarm will be generated, but I don't want to do that for every element. So I want to create that exception for those couple of special servers there. So I leave the base untouched. I cancel that one. And what I will create is I have an overlay here that I gave the name, meaningful name, overlay high memory. And if I open up this one, you will see there is only one parameter in there, the physical memory usage. And this one is indeed configured to be 99%. So, and be aware now it is important. Let me show all the parameters. That all the other ones are excluded. That's why this column is now the allow inclusion and exclusion of parameters is important, because in this overlay, I don't want to touch with any of the existing alarming that has already been defined in the base. No, I only want to make this one single exception on the physical memory, a special case on the physical memory, or maybe one or two. You can add some more if you want. So I only made this one 99 on the physical memory. Okay, and now how can I create a group? And let's here do our demo with creating a new group there. So I right click anywhere on the alarm templates, go once more for a new alarm template. The pop-up comes, but now I'm not going to create a new template once again, but I'm going to create a group. I'm going to combine those two templates that I just looked at. So that's our group example. If I take our group example, okay. So what can I do in a group, in a template group? The only thing I can do is just add a couple of existing alarm templates by clicking on there and selecting any of the existing alarm templates, which is the base I want to add. You can see all of the parameters immediately popping up. That's my result that will have that will be applicable in my group. There's only one, so it's just whatever the base was. And let's add that overlay for the high memory. But if I add that overlay for the high memory, let me see. I cannot. I will see, or let me maybe just make those a little bit smaller. Yes, then I will see it. Okay, so you will see that the physical memory here, it's still on 90 and not 99. Well, that's because it goes top to bottom. So the top, the base defines the physical memory, and it won't be taken anywhere else because it was included in the base. Therefore, I need to put the overlay and use the arrow buttons there on top of the base. And the overlay will now define the physical memory 99. You can see it's also indeed coming from the overlay high memory template. So it's coming from this template. This one defines the physical memory usage, but it was the only parameter in there. So all the other ones are being taken from the next step, the base, and the base defined all the other stuff in that resulting or consolidated alarm template that I see here. So if I now OK that, I will see that I have created a alarm template group. So it's a combination of two templates on top of each other. I can immediately assign it to an element. I'm not going to do it now. It has a special icon, so I could now assign it to one of my elements, and I would see that result of that 99 physical memory usage, which I already saw in the editor. So I'm not going to do it once more. Okay, so that's the alarm template group. Remember, that can come in handy to just, instead of immediately creating a duplicate, think about it twice before you do that, and maybe think like, okay, I'm only gonna make an overlay that just defines a couple of exceptional parameters. Then all of the base parameters, I only need to define it once in the base and not in a whole bunch of elements or templates. Now, a little bit of exercises. I do believe it's important, these alarm templates, so I will take a moment to do this quick exercises here that are defined in here. So I will create a new alarm template for an IRD element, one or more. I only will have one. I will enable some monitoring for my left test level and right test level, but I will do it if the output here, the mono output, is defined in off or left. It will only be left, or right, it will only be right. So depending on this one, it will activate left or right. That's the first step I want to do. Let's take a quick look at that, because I do want to do a little bit more practicing on that conditional and the monitoring in general. So what I will use once more my training element here, and I will create a, so I do have in here already configured a little bit of an alarm template, but I will create a brand new one by right-clicking on there and saying assign new alarm template. I don't care about any of the existing ones, new one. And it's opening up and giving me the possibility to define a exercise. Okay, so and I can immediately activate some alarming by activating the checkboxes. And if I will click on apply, it will immediately apply it on here. Well, I don't see a lot of difference. Let me disable the first one, audio output level. So we can see now my template is being configured or used on there. Let's maybe make it sure that it's visible in the window as well. So I have my new template that is created and assigned to my element. Okay. I have monitoring, and I can define the thresholds if I want, but I want to do a little bit of conditional monitoring. So to do that conditional monitoring, we're going to activate some condition here on the right-hand side. So if I go for condition, I can see I have new or no condition, because there aren't any defined yet. So I create a new one, and I will call this, for instance, disabled if off or this is right. If it's off, because it's left, it's only going to be active if it's left. If it's off or right, then it should be deactivated. And that's the this parameter here, the mono output. The mono, you can also type in there mono output. If the mono output value is equal to off, yeah, then it must be disabled. And this is already a little bit more complicated. That's why I want to do the exercise, because we didn't really do that yet. And or more specifically, or it will also be disabled if the value is off, or if the value is, if I click on there, I would want to go for that if it's right. If it's right. Always think twice. So if it's left, it will need to be activated, but if it's right, it needs to be disabled, or if it's off, it needs to be disabled. And make sure you make an OR combination, because they can be both active. Let's apply that and take a look at the result already. So the left plus right, they are both active. If I put it on off, let's put it on off, then I expect my left test level to be off. And if it's on right, it should also remain off. Now, to complete the example, let's do that also with the right test level. So I'm going to do exactly the same thing. Well, you have the existing conditions here, but I create a new condition. And this one needs to be disabled if off or left in this case. Okay, the mono output if it's off, okay, and mono output again, an OR combination, don't forget about that OR combination, or if the value is left, then it should also be disabled. So if it's off or left. So this one, the first one was off or right, it should be disabled. This one is off or left, it should be disabled. And now I need to apply it, of course. Don't forget to apply. If I put it on off, they will both be disabled. If I put them on right, then the right one should be enabled. If I put it on left, then the left one should be enabled. And if I, there we go, and if I put them on both, then both should be enabled. So that's the conditional monitor that we were taking a closer look at in this exercise. The second exercise, or the extension of the exercise, is that we can now also enable the monitoring for the audio output level. But we want to do that with a normalization that is configured on there. That we did already a little bit. I'm not going to do it on two elements, but you can also try that out on two examples. So I will enable the audio output level, and I will activate some absolute thresholds here. And I will say, for instance, if it's 3 more and if it's 3 less, I want to do some warning alarming. If I now click on baseline, it will say that it didn't find any parameters yet that are active for that. Well, I first need to apply, and then my element will be popping up. No, will not be popping up in there. No baseline found. Let me just reopen my my alarm template. I think there is a refresh here. So let me view the alarm template once more. Let's see if it now pops up, or maybe there was a little delay before it was going to show it. If I now click on the baseline, I see my trainer element, and it's currently on 12. Yeah, I can click on the set baseline. Remember, I can say copy the current value, then it takes the current value as the normal value, or I can tweak it manually by typing something in there and applying that to, for instance, let's say 15. Apply. Now it goes to 15, then it is already an alarm. So that's the baseline you define on there with the thresholds. That's the second exercise that was added in here. I thought it was important to also quickly go through those exercises because they are important and they were not fully covered, maybe at least the first part in the demos. All right, as you can see, there are a lot of features in the alarm templates compared to the trend templates. Trend templates was rather simple: activate, deactivate the average and real time. Here it's just activating, deactivating the alarming, but if you activate the alarming on a certain parameter, you have a lot of different possibilities. You define the thresholds, but you can also have normalization on there. You can have conditional monitoring on there. You can have anomaly detection on there. You have even auto clear or information alarms that can be generated. All of these features, like for instance the hysteresis, are there to make sure you have good and accurate alarming, but also you have manageable alarm templates that you can easily maintain towards the future. That is also something which is important and you have to keep in mind. So I hope you find it useful, this session, and I hope to see you in the next one.